Now let's talk about one last thing here. Let's say we have a surface that's like that. Okay, it's kind of like oriented. So we have a surface normal n, right? So what we do is we will sample directions on this hemisphere, but the hemisphere is aligned with the surface normal. Okay, so previously our hemisphere was aligned with the global XYZ system, but now our hemisphere is going to be aligned with respect to n. So I want to sample directions uniformly here. Now, how do we deal with this case? So like we have done before, we generate an orthonormal basis, O and B, around n. Okay? So here, when we generate the orthonormal basis, the up vector of this basis, or let's say the v vector, is going to be same as n. We are going to have a u vector, and we are going to have a w vector. Okay? So we must construct an ON orthonormal basis. Okay? So I will not repeat how we do it, but given a single vector n, we can construct an orthonormal basis. Of course, u and w are defined up to a rotation around n. Okay? So then any vector L here, let's say we have vector L, this is theta, and let's project this here. Okay, so we have phi, this is going to be phi. Okay, so it will be defined as any vector L. The u component of L, Lu, is going to be, what is it going to be? It's going to be sin theta cos phi. Lv is going to be cos theta, and Lw is going to be sin theta sin phi. Okay? So the components of the L vector with respect to u, v, and w vectors are like that. Okay? Now, then the mapping from this L vector to the global L vector is simply as follows. So we are going to say the actual L. So maybe I can write it differently. So let's call this L prime. Okay, L prime. Okay, so L prime is defined in the local space, in the UVW space. Now the L in the global space is going to be L prime u vector plus L prime v vector plus L prime w vector. Okay, so u, v, w are defined in the global coordinate system. We found them by creating this orthonormal basis. Okay, and Lu, Lv, Lw, L prime u, vw are the UVW values of this L prime vector, which we have uniformly created. Okay, so now how do we find Lu? Okay, so remember L prime u is equal to sinus theta cosinus phi. Okay, now let's use this, what we have here. Okay, so this is equal to sinus theta, but what is theta? Theta is cosinus minus 1. Okay, it's equal to cosinus minus 1 psi. Let's call it psi 2 cosinus phi. Okay, and cosinus, this is going to be 2 pi psi 1. Okay, so it's going to be like this. Now we are taking sinus of cosinus minus 1. Okay, now actually instead of doing this, we can derive a formula for this. Okay, now imagine, let's say we have a triangle, a right triangle like this. Okay, so this is, let's say, alpha, this is 1, this is psi, this is 1 minus square root 1 minus psi. Okay, now here we will derive something. Okay, so here cosinus alpha is psi. Okay, so from here alpha is going to be cosinus minus 1 psi. Okay, so what is sinus alpha? What is sinus alpha? Sinus alpha is equal to what is sinus alpha? So sinus alpha is equal to, I'm sorry, here I made a mistake. Okay, so sinus alpha is equal to 1 minus psi square. Okay, so from here you can see that actually if you want to compute the sinus of cosinus minus 1, okay, so sinus, so here alpha is equal to cosinus minus 1 psi, right? So you can take this and put this in here. Okay, so sinus alpha is equal to sinus cosinus minus 1 psi, which is equal to square root 1 minus psi square. Okay, so this means that instead of writing it like that, I can simply write 1 minus psi 2 square. Okay, this is more efficient. So instead of calling cosine minus 1 and then sine, I could simply write my result. Okay, and for the v component, LV prime, we have cosinus theta. So it's going to be cosinus minus 1. Okay, it's going to be cosinus of cosinus minus 1 psi 2, which is equal to simply psi 2. Let's write it better. It's equal to psi 2. Okay, and for the w, L prime w is equal to, again, 1 minus, we have sin theta, so 1 minus square root psi 2 times, this time, sinus 2 pi psi 1. Okay, so this is what we have found. So if you want to sample a direction uniformly around an hemisphere which is oriented arbitrarily around the surface normal, okay, the hemisphere is aligned with the surface normal, what you do is you sample LU, LV and LW using your random numbers, and then after you find these, you will substitute them in this formula, okay, which uses this LU, LV and LW together with the UVW vectors to find the global direction. Okay, it could represent a global, for example, light vector that from which I want to sample.